Good afternoon. This afternoon, we plucked Douglas Crockford out of Yahoo's offices in California to go into more explicit detail onto why JavaScript actually kind of rocks. So, without further ado, Douglas Crockford with JavaScript, the good parts.
And now the part you've all been waiting for, the good parts. So in any community of programmers, there's generally almost worship, adoration, admiration of the person who developed the language. Like the Python community is totally devoted to Guido, and the Perl community is totally devoted to Larry Wall. I don't know why, but they are. And the Java community is really into Gosling, and you know all those guys. But in the JavaScript community, there's no love. And I think that's a shame, because there's actually reason to love this strange little language. And I hope to convince you of that today, that the reason you want to love JavaScript is because it contains some good parts. So unexpectedly, JavaScript has become the world's most popular programming language. There are more people writing in JavaScript today than in any other language. Now, you wouldn't necessarily call all of those people programmers or competent or words like that, but JavaScript's got the numbers. And some of the people who are writing it are actually very good. In addition to that, there are more JavaScript engines running on more computers than any other language processor in the world. It's out there, it's everywhere. Although, ironically, at the same time, it is also the most unpopular language in the world. And this is in the sense that if you did a survey of any group of programmers and asked them, what language do you hate the most? Number one on everybody's list is probably going to be JavaScript. And that probably includes most of the people who are writing in JavaScript. So kind of amazing that one language would be on both ends of that spectrum. It's a language of many contrasts. JavaScript contains some of the best ideas in the history of programming languages. That sounds surprising, but it's true. And it contains some of the worst ideas in the history of programming languages, and maybe that's not such a surprise. But I'm not aware of any other language which sort of covers the extreme of the ridiculous to the sublime, as JavaScript does. If we look at the community of people who use JavaScript, we see the broadest range of skills of any programming language. We've got people who are doing computer science and really sophisticated engineering at one end, and the cut and pasters who don't even know that they're programming on the other end, and everybody in between. Now, trying to appeal to either one of those audiences is really hard. And somehow, having a language that works for both of those extremes at the same time is just amazing. And that's a remarkable achievement. And I think that's an indication that this language has gotten something right, despite its reputation. One of the reasons why people hate it, is because it is the language that people use without bothering to learn it first. Programming is really serious business, and you don't want to do it without sufficient necessary information in order to do it correctly. So you would never start programming in C without learning C first. You'd never start programming in Java without learning Java first. But in JavaScript, what the hell, you just start writing. And the language has enough expressive power that you can kind of get away with it, but it turns out that's a really bad strategy. And the symptom of that is that it will not work the way you expect it will. There's no reason why it should. And when you come up against those contradictions, it hurts. And people blame the language rather than blaming their own willful ignorance. So as a result, we hear a lot of complaints about JavaScript, and I think it's worth looking at them in some detail. The first is, JavaScript's not a language that I know. If I'm writing for the desktop, if I'm writing for embedded systems, if I'm writing for the server, I generally get to choose what language I'm going to write in. I generally get to choose what version, what brand of processor I'm going to use. But if I'm writing for the browser, the only choice is JavaScript. I hate that. I didn't choose that language. It's not one of the languages I know. So when faced with that reality, what most people do, this is what I did, was they just start writing without learning it. I'll show them. That turns out not to work very well. So my advice is, if you want to be writing in the browser, learn the damn language. Just It's really not that hard. It's a small language. There's a complaint that the browser programming experience is awful, and that's absolutely true. But it's awful not because of JavaScript, it's awful because of the DOM, the Document Object Model API, which is what the browser exposes to JavaScript, is one of the worst APIs ever devised. I used to say it was the worst programming environment in the world, but that was before I became aware of mobile. It turns out mobile is way, way worse than that. In fact, mobile is so awful that they are now trying to become web-like in order to take a leap forward. I mean, that's just how in the hole they were. So if you were to take your favorite programming language, remove all of the standard libraries, and replace them with the DOM API, you would hate that language. You would hate it forever. So that's just the way the browser is. There's a complaint that JavaScript isn't fast enough, that it's interpreted and web applications can't go as quickly as applications in other environments, and that's true. JavaScript could be faster, and we're finding that it is getting faster. But for most web applications, if the JavaScript engine were infinitely fast, most applications would run about the same speed, because it turns out the DOM, again, is the bottleneck. It's not the JavaScript execution. The browser spends a minority of its time running your script. The rest of the time is in doing what the DOM does, and it does it really inefficiently. Now, despite that, the browser makers are now in a contest to see who can come up with the fastest JavaScript engine, which is great. I'm really happy to see that competition. I'd be happier if they were trying to make the DOM better, but that'll wait for another day. But because they're making JavaScript faster, it means that JavaScript will now be a contender for a much broader class of applications. So it means we're going to be seeing more of it now instead of less of it. Then finally, there's the complaint that the language is just a big pile of mistakes. And my answer to that is no, it's not just a big pile of mistakes, because hidden under a huge steaming pile of good intentions and blunders, there is an elegant, expressive programming language. That is because JavaScript has good parts. A lot of people are surprised to learn that JavaScript has any good parts, but it does, and it's got some really good ones. I will show them to you today. I'll offer as one more bit of evidence that there's something right about JavaScript, in that it is succeeding very well in an environment where Java was a total, absolute, flat-on-your-face failure. The Java community doesn't tend to remember this, but I remember, because I invested tens of millions of dollars in doing Java applications. Applets didn't work. Applets were going to change the world, and they totally failed. Java went on and found a niche in the server side, and that's great. Happy to see that it survived and found some usage. But for doing the thing that it was intended to do, total failure. JavaScript is now doing what Java was intended to do, and is doing it really well. So the success of JavaScript isn't just that it's in the right place. There's more to it than that. So there are a number of influences on the design of JavaScript. From Self, we get prototypal inheritance and dynamic objects. From Scheme, we get Lambda, which is good, and loose typing. From Java, we get some goofy syntax and some weird conventions. And from Perl, we get a really awful regular expression notation. So before I get to the good parts, I think I need to go through some of the bad parts. This is by no means an exhaustive list. There's a lot more badness than I have time to go through, but these are some of the highlights. The worst of JavaScript's bad parts is its dependence on global variables. JavaScript doesn't have a linker, so the way it combines compilation units is it puts them all in a common global namespace. So they interact through their global variables, sometimes intentionally, sometimes unintentionally. This turns out to cause a lot of reliability problems, and it causes security problems. You've all heard of cross-site scripting attacks. That's one of the most profound security problems we have in the browser. It is a direct consequence of JavaScript's use of global variables. What makes it even worse is we have implied global variables. So if you have a function and you forget to declare a variable within your function, JavaScript assumes that you wanted it to be a global function. And for most functions, for most programs, you won't notice that error until sometime in the future when you collide against something else. Really, really bad. It uses plus to add and concatenate. This is a bad habit it learned from Java. In Java, it's not quite so bad because it's strongly typed, so you can predict which one it's going to do. But JavaScript is dynamically typed, so you can't tell by reading a program if it's going to add or concatenate, and that can cause problems. For example, you have a form element, and you ask the user to type a number into the input, and then you want to read the value of that input and add it to something. Well, it turns out the value that you get out of an input is a string, even though you and the user think it's a number. And so when you add it, you're actually going to concatenate it. And if what you're adding it to is some money, you might be alarmed at how big the number gets. JavaScript does semicolon insertion. This was a convenience feature added to make the language easier for beginners because it's based on C syntax. And in C, it's sometimes a little complicated to know where to put the semicolons. You have to pretty much understand the grammar of the whole language to know which statements end in a semicolon and which don't. So to avoid that, so you don't have to learn it, it puts the semicolons in for you, which is nice. Except that the way it does that is when the compiler sees a syntax error, it'll rewind a little bit, turn a line feed into a semicolon, and then try again. That should be freaking you out. Nobody should be happy with that. That's really scary. It's kind of surprising that it usually works. And when I say usually, that means there are times when it puts things in places where it shouldn't, and other times where it doesn't put things where it should. So my advice is put them in the right place. It's not that hard. We have a type of operator that tells you what the type of a value is, which is really useful. So if you give type of a string, it'll say it's a string. If you give it a number, it'll say it's a number. If you give it an object, it'll say it's an object. If you give it an array, it'll say it's an object, which isn't very helpful. If you give it null, it'll say it's an object, which is just wrong. It's just wrong. There's no excuse for that. It's just wrong. Now, I'm not talking about a bug. This is all standard behavior. The standard requires this. Everybody implements it. Everybody says that type of null is object. We have a with statement, which is so evil and diseased, I'm not even going to talk about it. We have an eval function, which gives you direct access to the JavaScript compiler and interpreter, so you can take a string and cause it to turn into action, which is potentially a nice thing, but the rules by which that happens gives that script way too much authority, and so it's a big security hazard. It turns out it is the single most misused feature of the language. So if you ever find yourself wanting to use eval, I recommend that you walk away from the computer and maybe not come back. Most languages have an array, which is a data structure made from a contiguous chunk of memory divided into equal-sized slots, and you can select a slot by a number. Very fast, one of the elemental data structures. JavaScript doesn't have anything like that. JavaScript has something that it calls an array, but what it is a thin veneer on top of a hash table. So you take that numerical index, turn it into a string, hash it, and then look into a bucket. So it works, but it's not fast. It does have one nice side effect, or a couple of nice side effects. One is you never have to dimension an array. There are no array bounds errors because there are no arrays, there are no bounds. It just adds things. And so it's actually a much safer construct than arrays generally are. It has an equality operator that does type coercion. That turns out to be a really bad thing. I'll show you why in a moment. And it's got way too many bottom values, including false, null, undefined, and nan. They're all falsy values. They're in some cases interchangeable, but they're not. And it confuses people a lot to have so many values that are almost the same, but are different. And I'll show you an example of that. So this is the consequence of doing type coercion while you're trying to test for equality. Yeah, transitivity. No, you're not going to get that. Now, these results are not random. There are actually rules that require this outcome. But the rules are complicated, and they don't yield useful results, in my opinion. Fortunately, we have a triple equal operator. which doesn't do type coercion. So it will produce false for all of these, which I think is the right answer. So my advice is, if you're working in JavaScript, never use the double equal operator, always use the triple equal operator. So one of the things we can do in this language is pass a name to an object and ask if it has a value associated with that. If it doesn't, you don't get an error. It just returns the undefined value. And so you can ask it, do you know what this is? And if it says it's undefined, then you know that it doesn't, which is a good thing. And so you can test for that in your program. But there are a lot of people who don't understand the difference between undefined and null, so they test for the wrong value using the wrong operator, which is two errors that cancel each other out, except they don't always cancel each other out. There are some cases where it's just wrong. But it's easy to get around this by always comparing with the correct value with the correct operator, and then it does the right thing. Some of the source of problems are due to good features that interact badly. For example, objects can inherit from other objects. That's prototypal inheritance. That's one of the things the language got right. That's one of the good parts. We can put functions into an object, and that's how we get methods. And that's really useful. And if I put the functions in the ancestor object of a bunch of instances, then they all inherit the method. And that's a really good thing. And then we have a for-in statement that'll iterate through all of the members of an object, and that's a really good thing, except it'll go all the way down through the inheritance chain and pull up those methods as well as the data values that you wanted. And that causes programs to fail. So that's a really weak pattern. So how did that happen? There was a design question. Should for-in do a shallow skim of just the topmost object, or should it do a deep dredge going through the entire inheritance chain? And at the time, they didn't know what the answer was. If they implemented shallow and it turned out deep was the right answer, then they were going to be screwed. But if they implemented deep and it turned out shallow was the right answer, then it could still work if the programmer has to filter the results. So that's what they did. It turned out the right answer was to do the shallow thing. But they didn't know that at the time. So they require that the programmers do the filtering of the results of for-in, but they didn't tell anybody. Because maybe if they'd explained that, it would have looked stupid, and maybe they didn't want to look stupid. So that's a trap. So we see a lot of problems coming from that. So I think a better design decision would have been to not release the language until we'd tried it for a couple of days and decided which was the right way to do it. But they didn't do that because at Netscape, getting it right was not an option, which is why there's no longer a Netscape. In fact, JavaScript should have died with Netscape, but it didn't because it has good parts. Some of the things that are wrong with JavaScript aren't really JavaScript's fault. They're C's fault. They were wrong in C and have been wrong in virtually every language since C. For example, you can have an if statement without a block as the consequence. You can have a simple statement. That turns out to be really fragile. The likelihood that that code's going to get broken in the future is way too high. You can make your code a lot more resilient just by putting in the curly braces. It's just 2 characters. It's cheap, and it's smart. We have an expression statement. So you can say something like name of a variable, semicolon, and that's a statement. And it doesn't do anything. It'll evaluate the variable, which is a do nothing, and then go on. So the reason for that is that I think it saved 2 productions in the C grammar. And I guess Richard was feeling a little lazy, so they did that. And that error has been copied in every other language since, including this one. The #1 most reported bug in the Mozilla database is some variation on 0.1 plus 0.2 is not exactly equal to 0.3. And this is not actually a problem with JavaScript. It's a problem with IEEE binary floating point. Almost all the modern programming languages have adopted this number type, and it is not able to accurately represent most decimal fractions. And that's particularly a problem in this language because the thing that people most use decimal fractions for in this language is counting money, which means the results come out wrong. When you add up people's money, they have a reasonable expectation you're going to come up with the right answer, and we don't. So what you need to do is multiply your dollars by 100 to turn them into cents. Now they're integers. Now you can add them. Then when you're done with your sums, you can insert the decimal point back in. You shouldn't have to do that. It would have been better had the language adopted a number type which more closely matched the way like human beings think about numbers, but they didn't. We got plus, plus, and minus, minus, which invite you to write code which is way, way too tricky. And generally, code which is too tricky is going to be troublesome. Most of the buffer overrun bugs that were in Windows were a direct consequence of plus, plus, and minus, minus. Some people like them because it's just too much work to type plus equal 1. The kind of efficiency where you can save one character is going to make a difference. I don't use them anymore myself. And finally, there's the switch statement. The switch statement was based on the Fortran computed goto statement. And one of the consequences of that is that you can have a case that falls through one to another. I'm going to tell you a little bit later about a program I wrote called JSLint, which is a code quality tool. And one day someone wrote to me and said, there's this problem with the switch statement, that when something falls through, it's really hard to find that case by reading it in the code. And it can take a long time to debug. It's really expensive. You're trying to find bugs early. Maybe you should give a warning on that. And I wrote back with this really long essay about how that's sometimes true, but there's an elegance that happens if you design your fall-throughs correctly that overwhelms the potential hazards, and so I wasn't going to do that. The next day, the same guy wrote to me and said he'd found a bug in JSLint where he had an error report that was wrong. You know where this is going, huh? So I threw it in the debugger, and it turned out I had a case that was falling through. And in that moment, I achieved enlightenment. It's really hard for us to learn from our mistakes. I'll talk more about that later, but it really is hard. And so I was fortunate that in this instance, it was so absolutely embarrassing that I couldn't avoid learning something from it. So now in my own practice, I never intentionally fall through. And that means I can easily find the cases where I accidentally fall through. And so I think I'm now using switch better. So finally, the good parts. You've all been waiting for this. Ta-da, here they are. It's a short list, but it's a really good list. Number 1 on our list is Lambda. Functions as first-class values, lexically scoped. One of the best ideas, maybe the best idea in the history of programming languages. Comes out of McCarthy's work with Lisp in 1958, perfected by Guy Steele in Scheme. At MIT, they've been doing this stuff for a long time and have been unable to get it into the mainstream, mainly because their syntax is so crappy. And so they're really powerful ideas that the market just never got to a place where they could understand. Amazingly, JavaScript is the first Lambda language to reach the mainstream and to get it right. So that's an amazing accomplishment. If there was no other reason to be aware of JavaScript, the fact that it accomplished that is quite an amazing thing. And beyond that, JavaScript has become an influential language. There are now other languages that are trying to figure out a way how to put Lambda into them, and they're doing it in order to be more like JavaScript. Who ever thought that would happen? That's just an amazing thing. JavaScript has dynamic objects. So instead of an object being a brittle thing that's an instance of a class, it's just a container. And you can put anything you want in it, including functions, including other objects. And you can make trees out of them or cyclical structures out of them. They're amazingly flexible. The amount of effort it takes to make an object is very small, very expressive, very powerful. Great stuff. We have loose typing. Now, most people would put loose typing on the bad parts list. I put it on the good parts list. So this is controversial, but that's all right. So it's controversial because the fashion of the day says that we want strong typing. In strong typing, you annotate your programs with types, your variables, your parameters, your properties, so that the compiler can detect a large class of errors at compile time. And the earlier we can detect an error, the less it will cost. And so that is a huge benefit. In fact, for people who are coming from a strongly typed background into a loosely typed language like this one, it's like really scary. How can you have any confidence that you're ever going to get anything working? And it's just impossible to understand how you could actually get anything done. And I used to go to that church. But I found that working with this language for a number of years, I discovered something which really surprised me. And that was that having strong typing doesn't mean you don't have to test. Because it turns out there's an even larger class of bugs that type checking doesn't find. So you have to test anyway. And I found that the amount of testing that I had to do for JavaScript was about the same as the amount of testing I had to do for JavaScript. The type errors and the things equivalent to type errors were found really quickly with trivial tests. And the errors that keep you up all night, the type system doesn't help you at all. In fact, sometimes it makes it harder. Because if you're building these deep hierarchies and you factored it wrong and you have to refactor it, that can be a lot of work, and sometimes you'll break things in the act of refactoring. And also, any type system which forces you to cast, I think, is fundamentally broken. JavaScript, you never have to cast. Everything's polymorphic all the time. It just works. So I've learned to like loose typing. I don't believe that I could convince anybody who believes in strong typing to change their mind tonight. But the simple fact is, if you want to write in JavaScript, you don't get a choice. You're going to have to learn to live with loose typing. And I hope my explanation will make it a little bit easier for you to adapt. Finally, we've got object literals. Object literals are a really nice notation for creating objects. You've got curly braces and name-value pairs, and you just make a picture of what you want the object to look like, and it is. It's just a really lovely thing. It was the inspiration for the JSON data interchange format. Code reuse is important because that's one of the ways that we avoid work. And work avoidance is probably the most important thing that a programmer can do. And there are two schools for how to do object-oriented code reuse, which we call inheritance. There's the classical school, which is represented by virtually all modern programming languages, and there's the prototypal school, which is represented almost exclusively by JavaScript. And it turns out, this may be a surprise, that the prototypal pattern is the more powerful one. There's more expressive power in the prototypal pattern, and the proof of that is that using the prototypal pattern, you can easily duplicate the classical pattern. And you can't do it the other way. In a classical language, you cannot easily simulate the prototypal patterns. But it also turns out that using the prototypal patterns most effectively, you don't want to be emulating the classical patterns because there are other patterns that are much simpler and much more expressive. And the inherent problem in this is that nobody knows that. Everybody's going to school where they learn to think classically, and nobody tells you anything about how to think prototypally. So you come to this language with the wrong experiences, and it doesn't work as well. So in prototypal inheritance, you're class-free. There are no classes. Objects can inherit directly from other objects. So in a sense, it's even more object-oriented. The way JavaScript implements this is that every object contains a secret property, a link, to another object through which it inherits material. This is sometimes called delegation and sometimes called differential inheritance. So if you ask an object for a property, and if it doesn't have that property, then we go through its inheritance chain and look to see if there's some ancestor who does. And if so, we deliver the property from the ancestor as though it had come from the object. The way we create one of these objects in JavaScript is using the object.create function, where we pass it an old object and it returns a new object which is empty, except that it inherits from the other object. This goes into the language in the 5th edition, which will probably be approved by ECMA International at the General Assembly meeting in December. So it's not formally in the language yet, but until it is, you can use this function, which will implement it for you locally. JavaScript is itself conflicted about its prototypal nature. It is prototypal all the way down, but it wanted to have syntax that looked more classical in order to make the Java kids feel better. And that turned out not to work. But making that attempt caused a problem. JavaScript has a new operator. So if you call a constructor function with the new prefix in front of it, it will create a new object and bind this on the call to the new object. But if you call a constructor function without the new prefix, like if you forget or if one of your users forgets, instead you will be clobbering global variables, which is a terrible, terrible thing. You will not be creating a new object. You will be smashing global variables. There is no compile time warning of this. There is no runtime warning of this. There's just destruction. I consider this to be a major design error in the language. And the way I cope with this is I consider new to be a bad part, and I don't use the bad parts. So I simply don't use new, and because I never use new, I never forget to use new. So let me show you a little bit of code. Let's see how JavaScript really works. So I'm creating a function here called digit name. Digit name will take a number and return the name of the number. And the way it does that is by looking up an element in an array called names. The problem with this is that names is a global variable. So if there's anything else in my application that's also called names, they're going to conflict. Or more likely, because of the dynamic way in which web pages are being built these days, there's something that I will never get an opportunity to test with that will collide with me. And either my application will fail, or theirs will fail, or maybe we'll both fail. And that's a really bad thing. It might be that I've got an ad on my page, and the ad brings in a names variable, and it causes my thing to fail. So I can't tolerate having any global variables on my application. So I want to rewrite this function so that I don't have that dependence. So one way I can do that is make names a private variable of my digit names function. And that works. So now functions have scope. We got function scope in this language. We don't have block scope, but we got function scope, which is pretty good. Names will no longer conflict with a global variable, and that's good. The bad thing about this function is that every time I call this function, I'm going to construct an array and stuff 10 things into it, 10 hash table insertions, and then extract one thing out. So that's a lot of inefficiency, and I want to avoid that. I want to be able to build that array just once. And using functions, I can do that. So now I've got a function, and it again creates a names variable. And that function will return another function that will make use of that returns variable. And what I'm assigning to digit name up at the top is not that whole function, but the result of the function, because I execute it immediately. Okay, and so what gets stored in digit name is this function. And because it is closed over its parents' variables, it will always have access to that even after the outer function has returned. This is an amazing thing. This is one of the most important properties of the language. If you remember only one thing from my rant tonight, this is it. This is a pattern. This is the most important pattern in the language. This is how you use functions to do amazing things. And it turns out there are thousands of variations on this pattern, but they all come down to the same thing about the lexical scoping of variables and how the access to variables continues to exist even after the outer function has returned. So let me show you another usage of this. I want to create a single instance of an object. And I want the object to have two methods in it, and I want those two methods to be able to share some private information. The way we used to write this is we take that shared information and put it in global variables. And that's obviously really bad, so we don't want to put it there. So instead, I've got a function in which I'm going to declare some variables, the shared state, and then I'm going to return an object. Here I'm returning using an object literal to construct a function, or construct an object which contains two functions, two methods, and those two methods will be closed over the private state that's created in the outer function. And again, I'm executing the outer function immediately. So what gets stored in the singleton is not the function, but the object. Everybody still with me? Okay, so that makes one object. What if I want to make a lot of objects? Well, in fact, that actually gets easier. So I can turn this module pattern now into a really powerful constructor. So we now have a functional constructor. So let me give you a recipe. It's a simple recipe. Step one, we make an object using any of the techniques available for making an object in the language. And there are a lot of them. I could use any of them, including calling another one of these powerful constructors, which sort of gives us another dimension of inheritance. Then step two, I define some variables and local functions, and these become the private members of the object we're making. Step three, I will augment the object with privileged methods. These methods will be privileged to have access to that private stuff. And step four, I return the object. So that's a pretty simple recipe. Let me turn it into a template so it's a little easier to see. So step one, I'm going to make an object, and I'm going to call it that. I would like to call it this, but this is a reserved word, so I'll call it that instead. And I can initialize it here any way that I want, or I could initialize it later. Then step two, I'm going to create another variable, a secret variable. This will be part of my private state. Step three, I'm going to create my privileged method. And my privileged method will have access to the secret. It will also have access to any parameters that got passed into the constructor. And it will also have access to that. And then step four, I return that. So it's a really simple pattern. But it makes really nice objects. And it gives us private variables, which is something that we thought this language couldn't do. And there are an enormous variety of ways that we can extend this. For example, if I decide that I want static variables, I want some shared state that all of the instances that this creates will have, I just have another function. And I put all of this inside of that. And its private function, or private members, private variables, become the static members of all of the instances that get built out of this one. Enormously flexible. And the reason why this works is because of what's called closure. And it's because a function object contains the function itself, the thing that has names and parameters and a body, the thing that executes. And it also has a reference to the environment in which it was created, or the context in which it was created. And that context is everything that was in the outer function that was defined inside of. So that's what gives it its access to the parameters and the variables of its outer function and its outer function and everything, because it's lexically scoped. And this is a really good thing. This is something that we first saw right in the actor languages and then in Scheme, and now finally in JavaScript, and now the world. So I need to talk about style. Style is important in all languages, and it's especially important in this one. So you can get two programmers talking and try to get them to agree on, do you put the curly brace on the left or the right? Is there a good reason to do one or the other? And they can go on for hours and hours about what they think the reasons are, but you listen to the reasons and they don't make any sense. But they're getting really emotional about it. They might even want to start hitting or crying or something, and they don't know why they're getting so upset about why it's got to be on the left or the right. And if you kind of deconstruct it, it may have something to do with where they went to school, or the convention used on their first job, or someone who influenced them early in their career. But they can't articulate a good reason, although they'll try, and they'll come up with a lot of things, and they're all just nutty. I think Thompson and Ritchie did the world a disservice when they designed B and C without saying, should they go on the left or right? They tended to put them on the right, but they didn't want to get in the argument. It was like, leave us out of it. And so we have to deal with this. So there's no good way to get people to agree on this. What you can get people to agree on is you got to be consistent. They're either all on the left or they're all on the right. You don't want to be sloppy. You got to be consistent. It's sort of like the argument about should we be driving on the left side of the street or the right. There's not a good reason for why we drive on one side or the other, but there's a really good reason for why we should all be on the same side. There are times when you just want to be consistent. And this isn't maybe quite that important, but it's easy to see the consistency principle here. We want to be consistent. But do you want to be consistently on the left or the right? For most languages, I have no idea what the right answer is, but I'm absolutely convinced that for JavaScript, you want to always put them on the right and never on the left. and this is why. So here we've got a return statement. I'm going to return an object. We've already seen a couple of examples where it's a really useful thing to be able to return a new object. And here I've got an object literal. And if I put the curly brace on the right, it works just as it should. And if I put the curly brace on the left, instead of returning a new object, it returns undefined. And there is no compile time warning. There is no runtime warning. If you're lucky, your program will fail immediately, and you'll go, whoa. But usually we're not that lucky. And so you'll take that value and store it in an object or something, and you'll come back several minutes later and have no idea where that value came from and how that value got clobbered. And you go looking at the code, and you look at that, and that doesn't give you any clue as to what went wrong. And you can spend weeks on this problem trying to figure out what the hell happened. So let's zoom in on this and figure out what the hell happened. So you remember when I told you about semicolon insertion, how it sometimes puts semicolons where it shouldn't? This is one of those times. So semicolon insertion turned this from a statement that returns an object to a statement that returns the undefined value. Now there's still a whole lot of stuff after that, so you would hope that something there would trip up the parser at least, and you'll get some kind of warning. Maybe it'll be a really weird warning because the context is broken, but at least it won't compile. Okay, so we've got a curly brace there that starts the object literal. Well, that's going to be misinterpreted now as a block. Now, an interesting thing about blocks in this language, we have blocks in JavaScript, but they don't have scope. And that turns out to be a source of problems, because most of the C languages have block scope and they have curly braces, and there's this really tight association between them. JavaScript took the syntax, but not the behavior. And so in most languages, the best practice is declare a variable as close as possible to the site of its first use. That's a really smart thing to do. But not in JavaScript, because we don't have block scope. So the smart thing in JavaScript is declare your variables at the top of the function, because we only have function scope. If you declare, people coming from Java or other languages think, okay, I've got I in one block and I'll have a var I in another block, not aware that both of those vars are the same variable. And again, there's no warning about that. So in a statement, or in a language that has blocks without scope, having a top-level block statement is completely useless. There's no reason to have that even in the language, because it doesn't perform any value. But we got it, and that's what it thought it had. Okay, so then we've got this OK colon thing. That doesn't look like a statement. Well, actually it is. It's a label. Now, there are only 4 statements in this language that make sense to have labels: do, while, for, and switch. And this isn't any of those. Now, C allowed every statement to have a label because it had goto, and every statement was potentially a goto target. JavaScript doesn't have goto, although the word goto is reserved. I'm hoping it never has goto. Oh, you laugh. Because JavaScript has become the most popular language in the world, it is also becoming the internet VM. We thought that the Java VM was going to have that role, but it turns out JavaScript has that role. So people are now translating Java into JavaScript in order to get it to run on the browser. And the people who are doing that have been asking us to make JavaScript a friendlier target language for them. And one of the things they're asking for is goto, so that they can write their own control structures and turn it into something primitive, so they don't have to map them on JavaScript structures. And we're not going to do that. We're trying really hard to resist that, because what we have found is every mistake, every bad feature in the language, really clever kids out in the wild have found uses for. And we all remember why goto was considered harmful, and we don't want to go through that again. Okay, so we've got this false statement. Well, there's no false statement, but what we do have is a useless expression statement. So what the compiler does is it looks at false and goes, yep, it's still a constant, and that's it. Now you might notice, well, that can't be a statement because it doesn't have a semicolon. Well, we got semicolon insertion, so that fixes that. Now you might notice that at the end of the block, we do have a semicolon, and a block never ends with a semicolon. But that doesn't give us an error, because another thing we got from C was the empty statement. the empty statement will consume all of the extra semicolons, suppressing the errors that we really want to have happening there. Now we've got all this stuff following a return statement. You can't possibly execute anything after return statement, so it doesn't make sense to have unreachable code there. JavaScript doesn't care. You can put anything you want after a block or a break, as long as it's syntactically okay, like this is, there's no warning whatsoever. So this is a case where bad style produces a bad result. And so my advice is put the curly braces on the right, never put them on the left. Now you might be looking at this and you might be thinking, this is the stupidest thing I've ever seen. And you might be wondering, how did this ever become the most popular programming language in the world? And you might be wondering, what kind of web standards process could allow this to happen? Because it's pretty obvious nobody was paying attention. Whatever caused JavaScript to become the web's programming language, nobody could have looked very closely at it, and somehow it just happened. In fact, given the way that web standards are created and maintained, we deserve something much, much worse than this. We deserve a language which is completely lacking in good parts, because there is nothing in the process that caused any assurance that there would be any good parts at all. Despite all of that, we actually have some really good parts. So I discovered all this stuff by trying to work with the grain. Like everybody else, I came to the language, not learning the language, and then hating the language because it didn't work the way I imagined it ought to work, when I had no reasonable expectation that it should somehow conform to my imagination. But with a lot of trial and error, and by closely reading the specification, which is horrible, the standard is really difficult to read, which is one of the reasons why most of the JavaScript books aren't very good, because the authors of the books are unable to read the standard, and so mostly what everybody's doing is copying crap that came out of Dreamweaver and just churning it over and over again. I mean, that's how everybody learned JavaScript until very recently. So it's no wonder that everybody's got all this stuff in there. The way I came to this, I was the founder and CTO of a company called Electric Communities. And one day, we had bought a chat system called the Palace, and graphical chat, and people online. And we thought maybe we were going to have an online community business. It turned out we were several years early for that, because at that time, advertisers didn't want to have their messages next to user-generated content, and that's all the content we had. So our timing wasn't good on that. But despite that, one day, Turner Broadcasting came to us and said that they were developing a children's collectible trading game based on Cartoon Network, and they would like to use our chat technology as the client technology for that system. So great. So I went down to Atlanta. I learned about the requirements, and it was really clear our little chat client was not good enough to do what they wanted to do. And I didn't want to walk away from this deal, because this was going to be really lucrative. So I don't know where it came from, but I got this really crazy idea. Maybe dynamic HTML could do this. Maybe I could do this in a web browser. So I wrote a little demo where I had some cartoon characters on the screen, and I could drag them and drop them. And I got it working on IE and got it working on Netscape and sent it to Atlanta. And they said, yeah, that's just what we want. And in fact, it was better than what we had proposed before, because it turns out you can't ask children to install applications. We hadn't thought of that. But doing it on the web, we didn't have to. So that turned out to be a good thing. So I went to my team. I had some of the world's best Java developers. And we'd been together for a long time. We had a lot of knowledge about how to build these kinds of systems. And I said, we're going to do this in the browser in JavaScript. And they said, great. What's plan B? In fact, we should start plan B right now, because this is crazy and this is not going to work. And I insisted, this is how we're going to do it. There is no plan B. We're totally committed to doing it in the browser. So who wants to do it? And everybody on my team did that. So I had to do it. So in addition to doing all the other stuff I had to do, I also had to write all the JavaScript on this thing. Managed to get it done on time and on budget. And in the process, I almost broke my hand one day punching a cubicle, because I was just so mad at JavaScript. But eventually, I had this epiphany. there are lambdas in it. Netscape never told us that there were lambdas in the language. They didn't tell us. I think the guy who designed the language was originally wanted to write Scheme for the browser, and they said, you can't do that. He kind of did anyway. Put C syntax on it, kind of made it look like Java a little bit, but it's kind of like Scheme inside, and he didn't tell anybody. And one day I was bicycling, and I had this epiphany, oh, it's full of lambdas. And that radically changed the way I thought about the language, and I stopped cursing it at that point. I still curse the DOM. I mean, that's still deserving of our curses. But I found stuff to like in this language. So I remembered an article that Von Pratt had published at the first POPL conference about a parsing technique called top-down operator precedence. Really, really clever technique where you take just a little bit of fluff in functions and you get a parser. And he was using it to put algol-like syntax on top of Lisp. And it turned out the Lisp community had no need for that because they really like their parentheses and they don't like anything else. So nobody ever paid any attention to top-down operator precedence. But here I had what turned out to be a functional language with syntax. And I thought, well, maybe it makes sense now. So I wrote a JavaScript parser in JavaScript, and it worked, and it was really easy. And it's like, wow, what do you do with that? Because it looks like sort of a useless thing. So what do you do with a useless thing? You write a paper. So the paper was published a couple years ago by O'Reilly in a book called Beautiful Code. So if you're interested in how to write elegant little parsers in JavaScript, you can go look that up. So I still had this parser and came up with another application for it, and that was to write a lint program. Back when C was a new language, the definition of the language was still a little squirrely because they were still working it out, and the compilers were pretty primitive. So there turned out to be a large class of mistakes that the compiler couldn't catch. And so someone wrote a program called lint, which would kind of go through and look for dirt and stuff on your program and give you better warnings than the compiler was able to give you. Since then, the language's definition has been firmed up, and the compilers have gotten really smart, so the need for a lint program has disappeared. But JavaScript really needs one, so I wrote one. It's called JSLint. JSLint provides a professional subset of JavaScript. It knows about the good parts and the bad parts, and it helps warn you so that you're using only the good parts. Because it turns out if you're just using the good parts of this language, you can do really well. But if you accidentally kind of get into the bad parts, as we've seen, you can suffer some real pain and misery. So in my own practice now, I never run anything without first putting it through JSLint. Some people think it's a debugging tool, but it's not. It's a code quality tool. It's something you do before you run, not afterwards. And it's free. You can just go to jslint.com and get it out. It runs as a web page. It has also been embedded into a lot of editors and IDEs and stuff, so it's all over there. One word of warning about it, though. It will hurt your feelings. It'll hurt them bad. It's just a mean program. Every once in a while I'll get a letter from someone where they've spent 2 weeks trying to debug something, and they send me the thing that they finally found and ask, is there some automated test you could put in that would allow us to find this quicker in the future? And so I'll put it into the program, and then I'll run all my old stuff through it, and it goes, oh man, I suck. It hurts so much. Even though I did it to myself, I still understand why people say it hurts. But the fact is, JSLint is a lot smarter about JavaScript than I am. And it's probably smarter about JavaScript than you are. So I recommend do everything it says because it's right and it knows what it's doing. So why is it so painful? Because once stuff gets in here and wrong, it's really hard to get it out. And most of us got it in here by reading all that Dreamweaver crap. So there's no question that our noggins are full of all this crap, and we're forced to unlearn it, and it's hard. It's really difficult. I get letters all the time from people complaining about what JSLint said about their code. JSLint said my shit stinks. What's up with that? Can you fix it? And they always describe their code with exactly the same 2 words. It was perfectly fine. They always say perfectly fine. And no, and part of it is that I didn't write JSLint for them. I wrote JSLint for me because I'm a professional JavaScript author, and there is so much flimsiness in this language. I just don't trust myself to write it without a tool like this. And I'm sharing it with the rest of you because I think you should be thinking the same thing. Apparently not everybody does. Josh Billings said, it's not ignorance does so much damage, it's known so darn much that ain't so. And that's true generally about software, and it's absolutely true about JavaScript. So getting back to the good parts, one of the very best parts about this language is its stability. There have been no new design errors introduced since 1999. The reason for that is the last edition of the ECMAScript standard was published in December of 1999. So it's actually been stable since then. And there's a lot of complaints that maybe 10 years is too long to go without a maintenance release on such an important standard, although this wasn't always an important standard. It wasn't until the Ajax revolution in 2005 that anybody paid any attention to JavaScript. So the language should have died with Netscape, and it didn't. So now in retrospect, maybe it should have been revised, and maybe it will. But it turned out the reason the Ajax revolution didn't happen until 2005 is really important. Everything that was necessary to do Ajax was in the browser and in the field in 2000. Everything, the fully interactive DOM, the XML HTTP request, everything was in place. But Ajax didn't happen until 2005. How many here have heard of Internet Explorer 6? Anybody? Anybody hate it? Even more hands go up. That's amazing. More, more people hate it than have heard of it. Today, IE6 is widely considered to be the worst web browser in the world. Is that right? I don't think anybody would contradict that. In 2000, IE6 was the best web browser in the world. It's hard to believe that, but it's true. It was absolutely the best browser in the history of the world and remained the best for many years running. The worst browser in the world at that time was Netscape 4. Netscape 4 was a crime against humanity. Netscape was trying to pursue an early mover strategy, so their theory was, let's ship crap, and it sticks and we'll win. And they shipped crap, and it didn't stick, and they lost. But it took years for all of those Netscape 4 browsers to get flushed out of the market. The half-life of a browser can be pretty long. And this one, it took about 5 years to get rid of it. And it wasn't until we got rid of the requirement to have our applications work on Netscape 4 that it became practical to think about doing Ajax applications. IE6 had to be not just dominant, but overwhelmingly dominant in order for Ajax to make sense. And eventually that happened. One of the things that's terrible about instability in the browser environment is you don't get to choose what version of the browsers you're going to run on. Your customers choose. And if you're on a mainstream site like mine, I'm at Yahoo, we have to deal with everything in the world. And the nature of web software is sort of different than everything else. Like if a browser maker makes a bug, then you get calls, you need to fix it. You didn't do anything to break your code. They broke your code. But you can't say, oh, it's Microsoft's fault. They'll get around to it. You have to fix it. And so you have to find the workaround. And then maybe a month later, they ship a fix. And maybe that fixed it. And maybe it introduces another bug. That's not uncommon. You have to work on both versions now. And maybe they'll ship another one a month later, and they'll finally get it right. Now there are 3 versions out there. And you have to run on all of them. So it just gets worse and worse. And nothing fixes that except time. It takes a long time for that to get flushed out. And it's not just time, it has to be stable over that time. So we had a lot of stability time, and that turned out to be a good thing. But that's all about to change now. So we've got a new edition of the ECMAScript standard coming out, hopefully to be approved in December, the 5th edition. It'll contain a lot of corrections. It will better conform with reality. We found lots of cases where none of the browser makers were doing what the spec said, and they were all right. So we're going to make this spec match. We found other cases where 3 of the browser makers were doing one thing and Microsoft was doing something else. We're now going to nail that down in the spec, so Microsoft will now conform with everybody else. We have support for object hardening, so you can now have an object and say, I want this field to not change, or if anyone attempts to change it, I want this function to get called, or I want it set up so it can't be deleted, or I want to modify this object so that people cannot add new properties to it. We're adding that to give better support for secure programming. Google's Kaha will be able to take very good advantage of these new features. We're adding a strict mode, which will finally allow us to begin deprecating some of the really bad stuff. The problem with JavaScript isn't that it has useless features, it's that it has dangerous features. And there are clever kids who have found exploits for all of the dangerous features and can show off. See, I found a way that I can do it without chopping my arm off. So I'm clever. And what we're trying to say is, it's great that you didn't chop your arm off, but maybe you really shouldn't be messing with that stuff. So we can't remove any of the bad parts from the language. All of the bad stuff that I've shown you, it's all still there. Like that semicolon bug, we can't fix it because we don't want to break the web. But we are adding a strict mode, which will take out with and fix eval and fix some other things. And that will be the thing that we will be building on going into the future. Right now, we're waiting for implementations. I expect Microsoft will be the first to get it finished. But they have to wait for IE 9 or something like that before they can ship it, and who knows when that's going to happen. Mozilla's also working on it, but I suspect that they want to ship it before Microsoft does, and they'll probably play tortoise and hare with them and wait until it looks like Microsoft's about to get there, then they'll run out ahead. We're trying to motivate them to do it a little bit more quickly. We don't know if that's going to happen. Apple, it's not clear what they're going to do. They've been coming to the meetings and everything and said, we finished the spec. Yeah. So you guys going to implement it? They said, well, we can't comment on future product directions. So we don't know what's going on with them. And then Google said, we'll do whatever Apple does. There's a lot of noise about the security problems with the browser, and JavaScript gets beat up a lot for its security problems and definitely has some. The global object thing is just inexcusable. But it turns out, because of its Lambda nature, you don't have to do very much to the language to turn it into a safe language. And we're seeing some really interesting experiments right now. There's FBJS from Facebook, which allows third-party applications to run on a Facebook page without stealing the identity of the owner of the page. Kaha and Kahita out of Google are taking capability object theory and pushing it into JavaScript. Really, really good work. Yahoo's doing it in all of its stuff now. Microsoft's taken it a little bit further with the web sandbox theory, which takes the same security ideas and also adds quality of service metrics to it as well, so that they can stop loops that run out of control, so that you don't have thread locking. In my own work in AdSafe, intended to make advertising safer, because it turns out advertising is a mashup. And so the advertiser on your page gets access to everything on the page, including the ability to write to your servers and everything else. Right now, the world's advertising infrastructure is built on the honor system, and it's not working. So we need to fix that. So we're looking at putting the stuff we've learned about object capability systems into the next edition of ECMAScript. Not the 5th edition, but something that would follow after, so that we wouldn't pay some of the performance penalties that Kaha and Web Sandbox are going to impose on script. So that'll be a really good thing. So finally, more good parts. Your JavaScript application can reach a potential audience of billions. There's no other application platform that can get you in front of that many people, and that's an amazing thing. You can get millions of people looking at your code. So even if JavaScript were totally crappy, it'd be worth the pain for the potential of getting in front of that many people. But it's actually better than that. If you avoid the bad parts, JavaScript works really well. In fact, there is brilliance in JavaScript. Amazing but true. There's actually brilliance hidden in this language. And for a long time, we thought it was not possible to write good programs in this language, so a lot of people didn't even try. I was guilty of that. But it turns out it is possible to write good programs. In fact, it's necessary to write good programs in this language because it's so flimsy that if you're not writing good stuff, it's going to do bad things to you. And that shouldn't happen to anybody. So one last thing, I wrote a cranky pamphlet about this material. So if you want to know more about JavaScript and maybe some important life lessons, you should go check that out. Thank you, and good night. So we have before dinner, we have a few minutes for questions. Anybody want to talk about anything? Is there a mic here?
You mentioned like name complex variables and global variables. Is there any name complex with global objects? And that's the same problem?
Global objects and global variables are the same thing. So there is one thing that's called the global object, which is the container of all the global variables. So that's the place where the collisions occur.
Did your solution solve that problem?
Yes.
Because of the private object?
Yeah. Yes.
Can you tell something brief about how JSON came to be?
Something brief about how JSON came to be. I actually have another hour-long talk on that topic. I'm trying to think about how to do it in a minute. I had an epiphany one day. We were trying to do AJAX applications, and it was obvious that XML was the wrong way to do it. And I came up with a way of embedding data in object literals inside of a script, inside of an HTML document, so that by sending the document, the data got delivered automatically with no effort. And it turned out to be really easy to generate and really easy to parse. And my partner, who was doing the server side of the application, used it for inter-server communication. He used it as a database. He used it for configuration files, applications that had nothing to do with JavaScript. So it became obvious that it wants to be language independent. So I formalized it because we showed the idea to our customers, and they said, "Oh, sorry, we can't use it because it's not a standard." I said, "Well, okay, so I guess I'll declare it as a standard." So I became a standards body. I'm JSON.org, and I said it's a standard, and I came up with this language-independent specification for it. So even though it's derived from JavaScript, it's really at the intersection of all modern programming languages. And by being at that intersection, it becomes an ideal interchange format between all programming languages. And I put this message format in a bottle and set it adrift on the internet, and it took off. How about that? What a story. Yes?
Mozilla's implementation of JavaScript has some nice extra features like being able to reassign the proto pointer and also no such method, but I rarely use them because they're not in all the other implementations. I've seen in ECMA 5 that there's going to be get proto of. Is there going to be setting up? I wonder if you could give some opinions about this.
So Mozilla has some extensions in it which allow you to set the prototype and some other things. No, we're not going to do that because of the security hazards. So the needs for web security are demonstrating that a lot of the things that Mozilla's been playing fast and loose with are going to cause us problems going forward. Which shouldn't be a surprise given our history. No such method and catch-alls is something we very much want to do. And so it's likely, I can't make any promises about what happens in the next edition, but I'd be very surprised if it's not there. Okay, let's eat. Thank you.